Welcome to NAPHN 20 and our conversation of why does COVID-19 hate Passive House. In it, we'll have a conversation with our panelists, our experts today, on the science of buildings and the relationship with the prevention of diseases. We'll talk specifically about the science, the mechanics, and the monitoring necessary to properly control the environment, the indoor environment of a building. I'm Beth Eckenrode, and I'm with the Oros Group, and I'll facilitate today's discussion. And I'm delighted to introduce to you our panel today. First, Bronwyn Berry, who might be quite known to most of you. Bronwyn's a registered architect based in San Francisco. She was educated in South Africa, holds a Bachelor's of Arts from the University of Natal, KwaZulu. Bronwyn founded both Passive House California and the North American Passive House Network, NAPHN, where she is currently president. She actively contributes to the United Nations Economic Commission for Europe's Coalition on Buildings, and that's more commonly known as UNICE. Bronwyn is considered a subject matter expert and has collaborated on a number of research projects with researchers at the Lawrence Berkeley National Labs. Welcome, Bronwyn. We also have Anjanette Green. Anjanette is co-author and director of standards development for Reset Air, the world's first standard and certification program, utilizing continuous air monitoring to measure the health performance of the built environment. With over 17 years of experience in sustainable architecture and design, Anjanette has served or is serving on advisory boards or peer review councils for Well Building, Fitwel, USGBC, and ILFI. In 2018, Anjanette was the recipient of the Living Building Challenge's prestigious Hero Award for her contributions to the International Living Building Institute. Welcome, Anjanette. We also have Dr. Berthold Kaufmann. Dr. Kaufmann is with Passive House Institute and conducts research on buildings and its many components. He advises architects, engineers, and construction contractors on passive house design for new buildings and retrofits. Much of his scientific work, along with that of the Passive House Institute, has been published on Passipedia. And that is to provide wider access to everybody with reliable data on temperature, energy consumption, and thermal flows. Welcome, Dr. Kaufmann. As a backdrop for our discussion, each panelist will review a few slides to set the stage for this conversation about building science, and ultimately we'll get to data science and how the two come together. Many things like the prevention of viruses have everything to do with the buildings, how they're designed, how they're constructed, and ultimately how they're operated. And we're going to get to that conversation. So without going any further, I'll turn the conversation over to Bronwyn Berry. Bronwyn, take it away.
Thank you, Beth. Thanks for that great introduction. So I'm really excited to be here today to really talk about ventilation systems in the COVID context from an architect's perspective, knowing full well that I'm by no means a mechanical engineer, but what I really realized from this entire COVID experience is that architects hold real responsibility for being able to deliver a building that can support healthy ventilation. And it really brought me back to the origins of why we build Passive House. And it started from this very esoteric sounding definition, which really, when you boil it down to the essence of it, this is hygiene ventilation. And this is what Passive House has always aimed for. So the simple way of translating that statement that's been codified by the Passive House Institute as the definition of Passive House was this ability for buildings to deliver 100% fresh air without recirculation, which is what all the engineers and the papers coming out around COVID-19 are really all advocating for. And in order to do this, if this is going to be our future goal for healthy buildings, creating that as the target is really what Passive House has systematically done since its inception. And where that started from was finding out, well, if we are going to be able to deliver 100% fresh air to our buildings, in order to do that, we can easily accomplish that in summer when the air temperature outside is wonderfully tempered and not cold. The challenge comes in the winter. And in order to deliver 100% fresh air to a building in the winter, when the outside air is cold, the building heat load has to be equal to or less than 10 watts per meter squared. And that was where the entire origination of Passive House stems from. And so the wisdom that was imbued in this thought experiment conducted back in the early 90s by Dr. Feist and Bo Adamson really looked at how do we achieve this healthy hygiene ventilation and create buildings that can get to this low load target to where this 100% fresh air ventilation becomes feasible and also economically viable in terms of energy consumption. And this is where the other elements of the building envelope and the building systems were all reviewed and calculated to work in service of this fresh air ventilation target. And of course, that is the origination of the Passive House standard. So if we look at the Passive House standard in relation to how our building codes have developed, and if the target for Passive House has always been hygiene ventilation, it's always a little tricky. I'm not going to go into this in too much depth, but it refocuses the entire goal of building design, which doesn't always align so well with how code has really looked at the development of buildings. In California, our energy code has been wonderful for many years, but the goal is not the same as what the goal has been for Passive House. The goal of our code has been energy efficiency at the cheapest way to go. And so this is something that we need to really revisit. And the COVID reality has really highlighted this complexity and this conflict in how our buildings have been codified and how they've been designed with the needs that they are now required to meet for this hygiene ventilation. So this is a paper that's been widely distributed. Some really wonderful reviewers and researchers have really all looked at coming to the conclusion that this hygiene ventilation, being able to design buildings that do deliver 100% clean, fresh air, is now the advised target in the COVID-19, in our new COVID-19 reality. And this is the graphic that they have shared, just an advisory instructions on how to deal with ventilation in these buildings. And I've taken the liberty of putting that in the context of Passive House to show how Passive House buildings can respond to this guidance and meet inherently meet the requirements for a healthy 100% fresh air ventilation. So, as you know, this idea of fresh air ventilation, providing balanced airflow into a building with heat or energy recovery, is very common in passive houses, and that serves the primary function of what this group of researchers has advised. But as I had mentioned previously, in order to achieve that and only create 100% fresh air supply, you really have to build a building to make it cost effective that has very low heating and cooling loads in order for this to actually be achieved. And Passive House can do that in a couple of different ways. The classic way that I illustrated previously is to be able to get the load down low enough to be able to supply the heating and cooling through the ventilation supply air. And then in other buildings, it's not a requirement that you do it that way in Passive House. There are many Passive House buildings that separate the conditioning from the ventilation supply through radiators and wall-mounted heat pumps that do offer some air recirculation to condition the air. But what I really want to show where Passive House really differentiates itself as an approach to be able to do, to meet these COVID-19 recommended requirements is it starts with a very rigorous source control measure, which is this air tightness requirement. So the air tightness requirement is not just a random requirement, but it really is very critical to be able to work in service of the ventilation supply, because there's really very little benefit in supplying ventilated air if you cannot control the source of it from all parts of the building. So it's again, air sealing is not just a random requirement, but it really does work in service, and as does the building envelope. So the building envelope, this additional requirement for insulation, for much more higher performance windows, and for no thermal bridges in that envelope, all work in service of the entire ventilation system and allow the heating and cooling, the conditioning, to be able to be delivered through that ventilation air. So again, it's this integrated, holistic approach to buildings where your building shell works in service of being able to deliver fantastically fresh air at a continuous rate and supply to the building. So if we look at that outside of the Passive House context, this was a wonderful slide shared by Paul Grahavok from Build Smart and Proseco, one of our supporters in the Passive House community. And he had quoted an article that based on a study that was published in Eckenrode magazine that looked at if we are going to now require buildings to supply 100% fresh air, this will have a 6 times increase in the energy use of buildings, which is enormous and completely goes against all that we have been working for our climate change carbon emissions reductions. And the only system that really will allow 100% ventilation to be delivered cost effectively actually is Passive House, this hygiene ventilation framework that we are all now being recommended by researchers. So I'm going to hand that over now to our next contributor, Berthold, who can share a little bit more of the details and the specifics.
Okay, thank you, Bronwyn, and thank you everybody for the introduction and to show the basics and the important things. I would like to share with you some ideas how to do it, and the first is, well, if you have this fresh air, what Bronwyn explained, coming from the heat recovery, you should deliver all rooms which are living rooms, or here in this example of a school building, office rooms and classrooms, supply air to the one room, and then a corridor used as a transfer zone, and take out the used air out of the toilet or storage room, or here some workshop rooms which maybe smell there. So you have an airflow from the supply air zone via a corridor or via a transfer zone to the extract air zone. And this is a very effective way to use air so that we do not need too much airflow, but have hygienic air everywhere. And the next slide, there are some hints about what airflow we really need to have hygienic air indoors. And you see here the 4 levels for indoor air quality from the standard. Indoor air quality 1, 2 is for special use, so for production or here and there, and maybe medical rooms. But we think for office use and for residential use, the indoor air quality 3 or maybe even 4 is enough. As if you would go with too much airflow into your rooms, there is a risk to be too dry air in winter times. If you take in dry and very cold air and heat it up, it may get even lower relative humidity, and therefore the recommendation is for a residential home 30 cubic meters per hour or about 18 CFM. And for non-residential use, so office building or classrooms or meeting rooms, down to 20 cubic meters per hour or about 12 CFM is quite enough. Yeah. So we know this is a compromise, but we think it's a good compromise to not to go to too dry air during winter time. Okay, the next slide shows you just an example for a filter. As you know, if you take air from outside, it may be dusty and quite dirty. And to get rid of this dust, you should filter your air. Well, and filter makes a pressure loss to the which you have to overcome with a fan power. And to have as low fan power as possible, you should go as a low, the lowest possible pressure loss. Well, and there are two things. Well, clean filters, only clean filters have the lowest pressure loss, so you should change your filters from time to time, and the minimum recommendation is once a year. And if there's more load in the air, you have to do it maybe every 2 months or every 3 months or something like that. Well, and here in the picture, you see a so-called bag filter. This is the best with regard to pressure losses. It's a very large filter area within a quite small box. Okay, and the next slide. You see just the an overview of a typical certificate. There in these certificates, what we Passive House Institute is delivering for evaluated system, you can see all the relevant numbers, what you need for PHP energy balance calculation. And please have a look to our website and our component database. There are many, many systems available, and you get everything what you maybe wish. Okay, on the next slide, just a few things. Well, they coming from China, and if you go for the session China Goes Passive, I will show you this in a little more detail. These are systems which were developed recently, the last year, which are combining the ventilation system and a heating and cooling system. So here below, the cooling coil is integrated to the same box as the ventilation system. So you get the fresh air from outside, preheated. And if you need more heating in wintertime or cooling in summertime, you can add the heating and cooling and probably add some recirculation air. As these systems are developed for apartments, so recirculation airflow is not a problem as it's only individually for your apartment, but as we will probably discuss later a little bit, fresh air is the choice for passive house, fresh air in and exhaust air out. And so we have a good indoor air quality at all. With this short overview, I will give the word over to Beth. Thank you very much.
Thanks, Berthold. So it's really a beautiful idea that Bronwyn started us off with, that the envelope offers itself up in many ways to the systems to allow us to control our environment. And we use this slide a lot with our clients when we talk about the importance of Passive House and its natural ability to drive energy low. But we use it as an opportunity to say there's more to that control over the envelope than just energy. And so when we think about the building science that allows Passive House, and then we transition over into a conversation about Reset Air, that brings in this idea of continuous monitoring. So not only does Passive House create the environment to have really good indoor air quality, but then Reset Air comes in and gives us the data science to add to the building science to understand and be able to track that performance over time. So I'd love to turn the conversation over to Anjanette Green for a deeper discussion on Reset Air.
Thank you, Beth, and thank you everyone for the opportunity to speak to all of you today about Reset. I think that it might be a standard that a few people are familiar with and others are not. So as mentioned, it's the world's first continuous monitoring and performance-driven indoor air quality certification program, which is a mouthful, but it actually needs to be all of those things. In developing this, it became much more than what we ever anticipated the standard to be. It is in fact 6 unique standards, all of which are necessary because of the complexity when it comes to looking at data and measuring indoor air quality. So the 6 standards that we developed all do very specific things, everything from telling you what kind of device is allowable for measuring, so an instrumentation standard, as well as data standards, who is responsible for actually aggregating that data and how to audit all of these different parties involved. So in developing this, we learned a lot. And one of those things that we keep hearing today, which is very pertinent to this conversation, are the different pollutants that we're responsible for. And currently in the standard, we are requiring these 6 different independent pathogens. So particulate matter, VOCs, carbon dioxide, carbon monoxide, temperature, and humidity. And you'll notice that in a lot of conversations that are particular to pathogens and helping to stop the spread of disease, a lot of the research is also looking at each of these different pathogens. So it's very convenient, I think, that the Reset standard has been asking for best practices that these be monitored just at the foundational level of our standard. Now, a word here about this slide, there's a lot of information on here, but we constantly are asked, what are the different performance targets? And it's different between your building typology. So this slide is showing on the top the commercial interiors thresholds, whereas at the bottom, they're slightly different for core and shell. And I want to take 1 second here to explain that one of the benefits and one of the things that makes the Reset standard with continuous monitoring very different from some other building schemes is that we have context-based requirements. So rather than just a flat or static threshold, we have a little bit of space for projects because we use an aggregate of data based on what is happening with your air outside. So I want to stress that because I know that a lot of teams across the world have become very discouraged with trying to attain certification for air quality certifications because they look at the standard, they look at that threshold, and they deem it too low for them to even try. So with Reset, we worked really, really hard and diligently to make a standard where everybody had a point of entry, and those projects in highly polluted areas still could celebrate the efforts that they were making to deliver good quality air to their building occupants. So this next slide, I think, I just like to show something that maybe more people are familiar with when they think of air quality, and they usually jump to the conclusion of spot testing or air sampling methods like you see here. This is the more traditional sort of requirement where you're asked to take a sample on site and that sample is sent back for a lab for testing. That is not the Reset standard. That is not continuous monitoring. Now there's validity to these tests and you do need them on occasion, but I like to explain Reset under the context of this sort of metaphor. Think of continuous monitoring as a video camera, where you're taking continuous data all the time so that you can have historical evidence from where you've come, and you can have metrics by which you can look to the future. Now, with a lab test or a one-time test, you're completely dependent upon what was happening in the building at that time and where you took that sample. So it's like a high definition camera. It might be really clear resolution, but it's only representing one particular spot in time. So it has its limitations. So with continuous monitoring, its foundation is 100% about the data. We are rooted in this concept of data. The quantity is not as important as the quality of it. And this goes deep to the heart and the philosophy of Reset. And it really anchors us, I think, in a time where we have a lot of unknowns. The science and the proof and the performance is really what everybody is digging into these days. And I think it's really important that we stick to that narrative. So how does Reset use data? Well, we have a three-tiered part of what we call our ecosystem. And what that consists of is, again, defining what kind of device you should be allowed to use. Now, we have a grading system as well as lots of explanations for fit for purpose. We want to make sure that people understand if you're going to put monitors in your space, there's a very big difference between those that are appropriate for outdoor installation and indoor, as well as we want to ensure that the data quality that's being collected has at least been reviewed by a third party. So we have accredited monitors. We also have accredited professionals. Now, these are trained professionals that actually have taken the time to learn the Reset standard technically inside and out. We take great pride in our Reset APs, and they are collected over the globe. So when you need them, they're at your disposal. And that last piece of that scenario is, again, that data provider, the person who is responsible for taking the data from thousands of devices and thousands of data points and aggregating that together in a way that A, can be audited, which is really important, that B, belongs to the owner, and C, actually has a process in the ecosystem where if you want to take that data and use it different ways, you can. You need not use it necessarily for certification. And again, I think that's a really important piece in our narrative that lets us stand apart. You can use the standard for things like Passive House, irrespective of if you want to certify under Reset. So what does this whole picture look like? This is a bit of a snapshot. Let's say you've got a series of B-grade devices deployed on your project. The information that's taken from those actually gets pushed up to that third party, that audited data provider, and that information can go up to the Reset Cloud. That is where you're actually looked at under your performance targets to determine whether you have certified or not. So in that whole picture, I think that again is really important for people to understand, because this is why we had to have 6 individual standards written to support this idea and concept of good air quality. The other piece in this slide coming up I want to explain is decoupling this idea of the HVAC system from the commercial interiors. So decoupling the people who are responsible for bringing air from the outdoors through the supply system is very important to decouple from the behaviors and those people like the occupants who might be generating pollutants. It's really important that we actually tease these things out. And business as usual is what you're seeing in this slide. The reason why Reset is so strong for most buildings who have been building according to older or perhaps more archaic types of ventilation systems is that you don't always have the ability to separate the air that's coming in from the HVAC system, ensuring that it's A, clean or filtered. And in addition, you're not really sure what kind of pollutants are being generated from the behaviors of the occupants and being pushed back into the building system. Now, we're going to talk about this in a second because, as you know, a lot of the recommendations right now from all of the experts and specialists are saying we need to bring in copious amounts of outdoor air. This has been part of the conversation throughout this presentation, but there's a big problem with that. There's a huge percent of the world that live in areas where they have high levels of pollutants. And I'm going to pick on PM 2.5 here just for a moment, because there was a recent study that shows that there is a higher rate of mortality from people who actually become ill from COVID if they are having long-term exposure. There's an 8% increase, in fact. So how can we actually feel good about making a recommendation to bring in outdoor air in large amounts to buildings that are not prepared for that? So I think we have a responsibility to understand that you solve one problem and create another. If you're going to be increasing the outdoor air and potentially bringing that in, a lot of these particulates and pollutants are going to exceed recommended daily allowances. We can't afford that right now. So the business as usual model is what Reset is hedging for. We're asking that teams monitor the outdoor air and that induct air. Those two things will allow you to better understand, are you making a difference in filtration? And then monitor their indoor experience, because I think now, while there's higher cleaning potential, more vacuuming, people who are actually spraying down surfaces while people are in a space, tracking PM and VOCs in your indoor air is highly, highly important under this context of COVID. So to wrap up, what we would really like to see people further understand is your building a responsive building? Is it nimble? Can you hedge against this event and others in the future? Do you have enough information from historical evidence, because you were actually tracking your data, to understand what would be happening for you in the future and potential remediation? Not just for COVID, we have wildfires, we have other events that could possibly be coming down the line that we need to be prepared for. So continuous monitoring, giving you that quality of data, and then making sure that you're doing what you can on the operations side to ensure that your buildings are healthy and as safe as possible. So the last slide here, I think, is a great one to actually introduce the new model, or not the business as usual, because where we had to design previously to ensure that our buildings were actually monitoring that outdoor air, you'll see one of the benefits of designing a passive house is it is by design already doing what Reset is asking for best practices. It's already asking that the occupants are covered by bringing in as clean of air as possible, just because of the nature and the requirements of a passive house. So putting those two pieces together is creating a beautiful relationship, not only because we have the additional benefits of energy savings and a smarter envelope, but you're complying with the best practices that Reset holds in its very definition and in its standard. And with that, I think I'd like to say again, thank you again to the team. I think, Beth, you had a couple of more comments to put in for this slide.
Sure, yeah, I just wanted to open it up to Bronwyn and Berthold in terms of when we talk about hygiene ventilation, and on the backdrop of everything now that Anjanette has said about Reset Air, and how Reset Air not only tries to ensure the quality of the air, but more importantly, continuously monitors it and then displays and shares that so that people know the quality of their air. So when you think about hygiene ventilation, we're kind of back to where we started, aren't we, Bronwyn? In that, you know, this is kind of fundamentally where Passive House lives. So when you think about this kind of a graphic, what comes to mind for you?
Well, thanks, Beth and Anjanette. I really realize sort of more and more that what we're doing is a real upstream intervention, and we're controlling the building. As Anjanette said, we're isolating it from the vagaries of the outside environment, which increasingly are becoming more and more inhospitable and random with our building envelope approach. And really, again, all of that is in service of being able to create this optimized ventilation system that actually can function and not require too much energy to operate. And where I love this merging of the Reset concept in actually documenting that, because Passive House does require testing and documentation of the construction process, but currently doesn't have any post-occupancy operational and monitoring requirements. So Reset actually does allow that quality control and post-occupancy monitoring to really be done rigorously. And perhaps Berthold can also speak to this, because I know at the Passive House Institute, you've done a lot of post-occupancy indoor air quality monitoring and primarily performance monitoring, but maybe you can speak to the indoor air quality monitoring, Berthold.
Well, thank you. What I really like is here that there's a system, a holistic system to do all this monitoring, so that the user afterwards can see is everything running as designed and as intended before. And so if everything is yet perfect, so if well, in normal operation, the problem is, or the question is my filter yet okay, or do I have to change? So if you can do it from time to time. If you have no monitoring, you should do it every year, I said before. But if you have this monitoring, you can see, well, if there's a problem with the filter, maybe a breakthrough or anything, you will see it on your systems, on your data. And well, if the pressure loss, I hope you will do the monitoring for the system, the performance of the system as well. If the pressure loss is going too high, you see, well, problem, change your filter and be happy afterwards. Yeah. So everything together, supervising is a really good idea, and we are asking for this many times. Well.
Yeah, I think that's interesting, Berthold, that the proof of performance, once you have the data and you can prove performance, it opens up so many avenues to think about commissioning differently and think about measurement and verification differently. And I think maybe as we go on to our last slide and we get into the discussion of COVID-19 and why it hates Passive House so much, I guess I would add one other piece to when we bring these two standards together, when we bring Passive House and Reset Air together, combine building science and data science, we really get after some of the threads that weave together the UN Sustainable Development Goals. And there's kind of a higher order opportunity, and you mentioned it, Bronwyn, earlier in the discussion about carbon. And I think even at a more actionable level, we get after a path to addressing fuel poverty and a pathway to address equitable indoor air quality. And so I think that this conversation, while started and really gaining some strength because of a virus, because of a global pandemic, we're now thinking about how to solve it in a way that opens up so many other opportunities. So along those lines, let me kick off a discussion amongst all of you learned people. And let me pivot off of a word that you all have used so many times when you talk about Passive House and Reset Air. In fact, Berthold just talked about it, and that is holistic. So a holistic approach is so important to the methodologies we're talking about here today. But what do you each feel are the biggest mistakes that teams make when they don't consider building performance holistically? And I guess maybe we'll start back with you, Bronwyn.
So thanks, Beth. Well, as an architect, I'm always amazed at how much our profession, my profession, actually abdicates responsibility for delivering a great building envelope so that the mechanical engineers actually have options. You know, really it's an upstream, as our keynote presenter this year really elaborated on. We have to be upstream thinkers, and we have that responsibility to deliver an airtight, thermal bridge-free, well-insulated envelope that actually allows our mechanical engineers to really explore these amazing opportunities that start to happen when you have very low loads. So, you know, that holistic, again, design integration that happens in the upstream design thinking and development process for buildings is critical, and architects have that responsibility. So really, again, not abdicating our responsibility and not seeing our really important functional role in this addressing of indoor air quality is key.
Yeah, there's an alignment that has to happen amongst teams against these, kind of noble goals. What are the goals of a project, and then how do you align everybody on a team? Anjanette, from your perspective in this notion of a holistic approach, because you not only look at it, from a functional standpoint, you're looking holistically, and that you've got so many of these standards working together. So what happens when people don't look holistically?
I mean, I think, the grand idea, of course, with any design is to understand that everything is connected. And that goes down to the materials that you choose and how you install them. I mean, all of that is going to have implications on air quality. If you forget for 1 second that the choices that you make don't have some kind of trade-off, if you don't make those choices right, you're going to end up with bigger problems that are a lot harder to solve, a lot more onerous for you to solve, and potentially a lot more expensive to solve. And that's if you can solve them at all. So I think that having deep conversations prior to actually looking at your design that encompasses a wide group of experts, you can have a confident conversation about best practices, end up saving everybody time, effort, and money. Now, getting everyone at the table to have those discussions can be difficult, especially in the past. As we said, the struggle has been a lot of people latch onto this idea that if you build something where the envelope is so tight, you're sure to have poor air quality. Well, it's just simply not true. So I think that, again, having the design with the data to show and prove what you're actually trying to achieve, and ensuring that everybody is looking at things on a holistic level, will end up having far more positive impacts. And again, couch you for any kinds of events that come in the future. That, again, I think is really something to take away from what we're learning in this pandemic, if anything.
That's great. Thank you, Anjanette. And I want to take a click deeper, Berthold, with you on this notion of hygiene ventilation and the article that Bronwyn mentioned, specifically about how passive house is the most energy efficient approach to reaching hygiene ventilation, and that conventional construction can be as much as 6 times more energy intensive to reach hygiene ventilation. Can you explain maybe in kind of layperson terms what it is about passive house that makes that so?
Well, when we are looking for the question how to prevent us from the danger of the COVID and other viruses, we are looking for fresh air coming from outside. And Anjanette said, well, fresh air is not always fresh. You have to check if it's really good air. So we have to filter, but mainly we are looking for fresh air as the concentration of potential virus danger is as low as possible. So meeting outside in this COVID period, meeting outside is not at all dangerous, because in outside air, the concentration of the virus is quite low. So taking in outside air is a good idea to keep our indoor air quality good for living. Yeah, and this is the idea we had from the very beginning, and Wolfgang Feist said from the very beginning, we want to work with fresh outside air, and we want to avoid as much as possible any circulation of air, because this is dangerous, especially if you do it with a multifamily building, mixing air from any apartment to the another, or mixing air for a large office building, so that everybody gets a cough if one has. Yeah. So fresh air is the solution. Well, and now comes the question. If you open windows to have fresh air, you get cold air in, and this is not comfortable. So people will close windows as soon as possible, as soon as they can avert. Well, and and the solution is quite simple: do this heat recovery. Yeah. So the exhaust air going out shall give the heat over to the air coming in, with no mixing, so airtight inside, no mixing. And well, so you have the fresh air, but you have a better temperature, and you have a comfortable living all the winter. Yeah, and you have this low energy impact, if you have about 90% heat recovery, the heat losses are low instead of, and the heat losses are low and you have the good air quality. Well, it's quite simple, but we have to emphasize in those time again once and once more. Well,
that's great. And one more question before we get to kind of our group wrap up. And Bronwyn, maybe you could click a little bit deeper on this notion of what measures are there beyond standard ventilation and envelope design used for passive house that you would recommend?
So having spent the last 3 summers dealing with wildfire issues here in California, in my projects here, we really realized passive house is the baseline. You know, we are going to be coming into even more wildfire seasons, and this is just going to be an annual event. And we're realizing adding additional filtration to our heat recovery ventilation systems is essential. And then as the recommendations have been for interior air cleaners that will actually support additional microfiltration is going to become really standard. I think what we really need to realize is passive house is where you begin to address these health and indoor air quality issues, but you have to even potentially go further. And Anjanette even mentioned materials toxicity, making sure that we're actually controlling and regulating other toxins that we bring into our buildings. Passive house can help with that with the regular ventilation supply, but it doesn't eliminate it. So really baseline basics start from the beginning, and passive house exactly starts there, but we have a long way further to go.
But that's the whole point. It's the whole point, isn't it? That if you try to do those other things, those added things that you're talking about, and you haven't shored up your envelope, you don't have control over your environment. It's a little bit like pounding your head against the wall, right? Like you don't have a holistic solution. You have an attempt to mitigate something specific, and that whole mitigation becomes that much more difficult.
Absolutely. It's the leaky bucket analogy. You can't plug a bucket with gazillion holes in it. So you have to start with a solid bucket. Right. And that's what our buildings, where I have to begin. And even the monitoring and the source control, it's just fundamentals. First principles is where we have to really start from.
So I'd like to end with a piece of advice. I'd like you each to give building owners, practitioners, a piece of advice as they think about controlling the environment as it relates to indoor air quality, virus mitigation, wildfire mitigation. Just what one piece of advice do you have? And Anjanette, I'd love for you to start.
My advice would be, first of all, understand your building type. Understand how it may have changed under this lens of COVID and honor that, but don't rely on that as the continuum. This is an event that we will get through, but in the interim, learn as much as you possibly can about your building, your ventilation system, so that when we can actually move things back to normal, you start to have historical evidence. This is a prime time for you to invest in as much as you are in perhaps organizational changes, administration changes. Look at your building, your typology, and invest in some monitoring so that you have it moving forward.
Yeah, the baseline is so important, isn't it? Just to establish where you're at today. Bronwyn, what about parting comments?
Really, I was going to echo much of what Anjanette has said. If you don't know where you're starting from, you have no hope of getting where you need to go. So air tightness, blower door testing, start with understanding the fundamentals of what you have in your building, and then craft a plan for where you need to get to. So that's just really, it's just It's like an economic building business plan. It's exactly the same steps. So apply the same principles.
That's great. Thank you. And Berthold, any last comments or advice for our watchers?
Well, to make the building the best you can, obviously, yes. But I would like to end up. We should get the problem from the root. So the bad air, the very bad air, what we have seen in the picture, we should get clean. Yeah. And this is get your fossil fuels and the dust, what we do emit with power plants and so on. This we should reduce, and then with that we come to the beginning when we are starting. And Wolfgang Feist was starting with Passive House. He said, well, the consumption and the demand in energy, what makes the problem, this should be reduced. Well, and then in the end, we come to we see that there are some other benefits from the a good passive house, a good building shell. So we have good indoor climate, but please don't forget where we started in the beginning. Well,
that's right. Well, thank you. And thanks all of you for your comments and your really wonderful conversation. I think to summarize what we're saying is, take it on, tackle it, get the baselines established, but don't be afraid, because Passive House and Reset Air are no regrets moves, and they shouldn't cost you a whole lot to get there, but they're no regrets moves to low energy and ultra high indoor air quality, and we should be able to get all of them, shouldn't we? Thank you all.